Us and welcome to lesson 1.2, what is a function? Now, since we're doing a flipped class or you're just watching this video, I will let you know that quite often I start my lessons with warm-ups. Now, warm-ups will either be testing last day's assigned work, or it'll be something getting us ready for today's lesson. All right, so you can expect to do warm-ups frequently in these lessons and in these videos. So what I suggest you to do is, if you know how to do this, by all means, stop the video, do it yourself, and then press play on the video again to check your answers. Okay, so number 1 says to create a table of values for each of the following equations. Hopefully, ladies and gentlemen, you recognize for A and B that both these equations are what we call linear relations. Okay? Otherwise, you may remember from grade 9, we related them to y equals mx plus b, where b is your y-intercept, and m is your slope or rate of change. I'll just put rate in background. Okay? So how can we recognize it's linear? There are no visible exponents. Okay? But what we also need to remember that when we take a look in grade 9, we had independent versus dependent variables. This is the independent variable because we can set it as 0, 1, 2, 3. We can set it as whatever we want. Sometimes people call that the input value. Okay? And y is what we call your dependent variable, and that's going to be your output value. So if we're asked to complete a chart, I will show you more work that's necessary, and I'll show you what part you need to show me. But what you do is you remember, we start with an initial substitution, so we're going to let x be 0. So in this equation, wherever we see an x, we're going to put a 0. So let's rewrite this. Y equals, instead of x, we write a 0 plus 3, and we simplify 0 plus 3 is 3. So our answer is going to be y equals 3. Next, let's do another substitution. Now we're going to replace x with 1. So wherever we see an x, we're now going to put a 1. So y equals 1 plus 3, which means y equals 4. In the next one, ladies and gentlemen, we're going to replace x with 2. So it's going to be y equals 2 plus 3. So y equals 5. And in the last one, we'll take a look at, we're going to let x equal 3. So it's going to be y equals 3 plus 3. And y equals 6. All right. So ladies and gentlemen, this is just the rough work that you can put down if you need to. But when you are asked to complete a table of values, as long as you give me the answers, which are right here, I'm okay with that. Okay. I also want to point out some trends here. First of all, taking a look at this equation in A, y equals mx plus b. B equals 3. And just remember, guys, that is the y-intercept. And where does the y-intercept occur on a graph? Whenever x equals 0. So that's a double check. So if you have given a table and you need to find the y-intercept, you look for the value of y when x equals 0. So there's another way that tells you b equals 3. The next thing we're going to take a look at is slope. Slope in this case equals 1. And remember when we were talking about the rise and the run of slope, we made it into a fraction? So 1 can be rewritten as 1 over 1, which means we're going to rise 1 as we run 1. What does that mean? Each time we increase one number in the x, we increase one number in the y. Okay, so basically that's the rise over the run. Okay, so these are interlinked. Remember, a relationship, ladies and gentlemen, can be shown in many different forms. It can be in word form, an equation like this, a table of values like this, and we're going to graph it down below like this. Okay, so if we said something like Johnny makes $5 per hour, you could say y equals 5x. You could create a table of values, and then you could graph it as well. Okay, so a relationship can be shown in many different forms. Let's take a look at we'll do part B of the table and then we'll graph them in number 2 after. Okay, so again, we take a look in example B. We notice it's a linear equation. It's in the form y equals mx plus b. And we're going to do a substitution wherever we see x, which is your independent. We sub it in and find y, which is your dependent variable. So we're going to go y equals -2 times -2 plus 6. Simplifying that through, we know that y equals 10. Okay. Next substitution, y equals -2 times -1 plus 6. And that's going to simplify to y equals 8. Remember, folks, if you need to use your calculator to figure this out, by all means do that. Okay. Next one, y equals -2 times 0 plus 6. Anything times 0, folks, is 0, but then you got to add the 6. So y equals 6. And substitute for 1. Y will equal 4. And y in this case, for the last one, -2 times 2 plus 6. Y is going to equal 2. Just remember, folks, that these are going to create your ordered pairs, which would be, if you're plotting it, -2 and 10, -1 and 8, 0 and 6, 1 and 4, and 2 and 2, just if you're forgetting what a table represents. Okay? So now we're going to learn how to graph these. Remember, there's 3 different ways to graph a linear relation. One is using the ordered pairs that we have. So for example, I'm just going to make this a little bigger for you guys. Make that bigger so you can see. Okay, so going back to our table of values, first one is 0 and 3. So 0 on the x, 3 on the y. There's 1 point. The next point, folks, is 1 and 4, 2 and 5, and 3 and 6. Okay, these dots have a linear trend, so we're going to take a line, and we are going to draw a line through them. Okay, and we're going to make sure that we put an arrow on both ends. So I have to do that. Just give me a second. It takes a little bit longer on the computer to do that. Okay, and then, ladies and gentlemen, we've got to label it. So we're going to write the equation down, which is y equals x plus 3. That's one way to draw it. The other way is to remember the things we talked about up here, which is the slope and the y-intercept. So this is the shortcut way to graph it. Okay, and I'll go over this way. Hopefully you remember this one from grade 9 as well. So b equals 3. That's your y-intercept. So you start at 3 on the y. Remember, x is 0. That's it. Okay, then we do the slope. And the slope in this case equals 1 over 1. So you rise 1. So go up 1 and over 1. Draw a dot. Up 1 over 1. Draw a dot. Up 1 over 1. Draw a dot. Okay, that's a short form way to graph a linear relation. All right, let's try the second one using the shortcut. If you have a blank grid like this, ladies and gentlemen, put x and y to label your axes, and then to show me a scale, as long as you put a value, one number, in all four quadrants, I'll be fine with that. Okay? Sorry about that, guys. Just give me a second. Okay, so ladies and gentlemen, according to this equation, we have y equals -2x plus 6. In this case, the b equals 6, so b equals 6. So what I'm going to do is on my graph, wherever I see 6, 2, 4, 6, I'm going to draw a dot, and then I'm going to take a look at my slope. My slope in this case is -2. Okay, I'm going to make that into a fraction, -2 over 1. So it's supposed to be rise over run, but when it's negative, you actually fall, right? Hopefully you remember that. So from my ordered pair of the y-intercept, I'm going to go down 2 over 1. So fall 2, run 1, fall 2, run 1. Remember, you always run left to right. And we see that there's a linear trend there, so we're going to draw a graph. Okay. Extend it, and then I need to just change the end to make sure that it is an arrow. Good. And if you don't have your if you have your equation right above, that's fine. Otherwise, write it right on the line. All right, here's our warm-ups. So now today we're going to go into doing what's called a function. The lesson title is What is a Function? Now you might say, hey, Miss R, I haven't heard of function lately, but believe it or not, you've been doing function work since you were probably in grade 5. Remember that activity, guys, where you started with one of those connecting cubes, and then you wrote down, hey, 1 cube, it has 1 cube total. Then you do one step where you add the cubes on each end, right? So then in step Next step, you'd have 3 total, and then you'd add 2 more, and you'd have 5 total, and then you add 2 more, and you'd have 7. That's actually a relation, and now we're going to learn how a relation becomes a function. So let's take a look on the next page for some definition, and let's get into what a function is. Okay, what is a function? Here's your title today. Okay. A function is a rule that gives a single output number for every valid input number. The easy way to remember it, and I don't mind you using this on the test, is that every x value, there is only one y value. Okay? And we're going to take a look at how we can express this rule to explain what a function is. So this rule, or this function, can be explained either as an equation, so y equals mx plus b, for example, a graph like we just did in the warm-up, a table of values like we just did in the warm-up, or in words, Johnny gets paid $10 per hour. Okay, that's a rate. So it can be expressed in many different ways, and hopefully from grade 9 you learned how to switch each of these methods of explaining or expressing a relation. Let's take a look here at how do we develop a rule. Okay, now a rule can be any 4 of these. However, if the equation's given, you can't give a rule in the equation. You've got to change the format. So let's take a look at A. It says y equals 3x. So the equation 1 has already been given, so we're not going to be able to use that. So we can either graph it to explain it, table of values, or words. I think words is easy, and it depends on your input versus your output. So the input is the x, as we learned in warm-ups, or the independent. So you're going to say, hey, take a number, and then what do we do to it to get at 3x? We take a number, and then we multiply by 3. So multiplied by 3 gives the y, which is your other number. So gives the other number or value. Okay, it doesn't matter. Okay, or you could say the input number is multiplied by 3 to get the output number. Okay? Taking a look at the second one, again, it's an equation, so we can't use equations, so let's use words. Okay? So we're taking a number, and what's different this time? Are we multiplying it this time? No, it's got us 2 as an exponent, so that's called squared. So a number squared plus 2, but you've got to add 2 onto it, equals or gives the other number. Oopsie, spelling mistake. Here's live video. Thanks for bearing with me. Okay, so that's one way to express a rule. Taking a look at C, ladies and gentlemen, we've got a table of values. Okay, you could take a look at the pattern and say, hey, what's happening each time? So for every increase by 1, there is an output value that adds 2 each time. Well, how do we figure that out? Well, remember what we used to do to table of values to see if it was linear or not? Remember these things, guys? These are called first differences. And your teacher may have shown it differently, but I do delta y, which means change in y. And just so you remember, it's the lower number, subtract the upper number. I'll just do that work for the first one. And then you realize when you take the lower and subtract the delta y, so the change in y is 2, don't forget to do it in x. Okay? So the change in x is 1 because that's what we've set up for the independent. Okay? So what does that tell us? For every increase in the input value, so as I go from here to here, so as I increase the value input by 1, I'm increasing the output by 2, so it adds 2. So you could use that for words if you wanted that. So for every increase by 1 of the input value, the output adds 2. It's one way to do it. However, I like to, whenever I get a table of values, I like doing the equation as a rule. Okay, so hopefully you can remember from grade 9, we want to end up with y equals mx plus b. And we can get some information from the graph. For example, I'm just going to have to draw a line here. Okay, for example, we know that there are a couple formulas for slope. We've got y equals rise over run. That was if you've got a graph. We also remember that if we got two ordered pairs, it's y2 subtract y1 over x2 subtract x1. But hopefully you learned the one when you got a table of values, which is change in y, delta y over delta x. What does that tell us? That tells us that slope equals, for this case, if we sub it in, delta y is 2 over 1, which tells us the slope equals 2. So that's one part of the y equals mx plus b. We now need to find the b. So in order to do the b, how do we figure that out? Well, the b is the y-intercept, and the y-intercept occurs when x is what value, guys? When x is 0. So look at our pattern. We've got 4, 3, 2, 1. If I go up this way, I can add a 0 in here and follow the same pattern. So if I'm going 10, 8, 6, 4, what do you think that's going to be? That's going to be 2. So you can actually add values in because it's linear, and you get the b equals 2 from that. So what do we know now? B equals 2. Since we've got the m and the b, we can sub it in. So since y equals mx plus b, let's sub those in. Y equals your slope, which I'll put in blue because that's what we were doing, x plus b, which is 2, which I'll just put in green. Okay, so that's your slope is the first one, and your y-intercept is your second. Just happens to be the same. Okay, so that's another way to explain it. Okay, all right. The last one here, which is hidden, is d. Now, d is given in words, and we've got to probably figure out how we want to do this. I would say the easiest is to put into an equation if the equation isn't given. So it says multiply a number by 4 and subtract 2, and that will get you your other number. So multiply a number. Remember, whenever we're using algebra, we kind of let the number be represented by x. So I'm going to write down x, and it says you're going to multiply that by 4. So what do I have to put that? So it says multiply by 4, so it's going to be 4x, right? And then it says to do what? Then subtract 2. And that will give you your other number, which is y equals. So there you go. Y equals 4x minus 2. And that is your rule for D. All right, keep moving on. Now, graphs. Graphs have a special way of determining if you have a function, if your relation is a function. We do something called the VLT, or vertical line test. On my unit test and on my exams, you can use VLT for short form. It's not like last year where you had EQO and you had to explain everything. I will understand what VLT means as long as you know that means the vertical line test. Awesome. So what does it tell us? It says for the vertical line test, given a graph of a relation, it is not a function if at least one point is drawn through the graph passes 2 or more points. Okay, it's more confusing to explain it. Let me show you how to do it on the graphs below. All right. Okay, so everything we're going to be talking about are relations, and that's what we've been doing in math. But we're now going to take a look at specifying when is the relation a function, which means we're further classifying it. We're making it more specific. Okay. Once we've tested that it's a function, so once we've said, hey, yes, this is a function, then we can discuss if it's going to be a linear function. Remember, a linear function is when you've got a straight line, or if you've got a non-linear function, that means it is not a straight line. So most cases, it's going to be curved or broken up. Okay? So in most cases, it's a curved line. All right, ladies and gentlemen, please, you do not need to write these down, example 2, because you're going to be doing this as part of your homework. So just kind of sit back and watch. Okay? So you'll be doing homework just like this. So I just want you to have this as an example. So you don't need to do this with me. Okay, it says identify each of the graph, if each graph is a function or not. And if it is a function, decide if it's linear or non-linear. So the first thing you're going to do, if you are at home, ladies and gentlemen, get a ruler or a straight edge, or even use your pencil. Because I have a smartboard, I'm going to have some fun by drawing a big, hopefully make sure it's a vertical line. Okay, I'm going to pretend this is my pencil. And what I'm going to do for the vertical line test, and just watch what I do here, as I scan from left to right, I got to make sure that only one point hits my line at a time. So if I do this first one, notice we're still okay. It's just one data point, so we're good. So far it's still a function. I hit this one, so far I'm still a function. And then when I hit this one, notice how 2 points are on there at the same time. So these two data points, because each x has to have its own y in order to be a function, notice when x equals 1, y equals both 2 and 5. So that tells you right there that this is not a function. So we're going to say no, because it does not pass the VLT. If by chance, folks, I had just taken and didn't have this data point here, it would definitely pass the vertical line test, okay? Because there wouldn't be 2 points competing. I will just clear that back up. All right, let's look at B, okay? So I'm going to use my same ruler, okay? Looking as I go from left to right, notice each time when I scan through that there's only 1 point hitting my red line at the same time. So this will tell you that yes, this is a function because it passes the vertical line test. So yes, because it passes the VLT. Okay, and then it said, remember that if it's a vertical line test, tell me if it's linear or nonlinear. Now, you might argue, Ms. R, there's some straight lines, but is it a one continuous straight line? No. So this is where it's broken up. So this is a nonlinear function. Okay. All right, 2 more and then we're done our lesson. So I'm going to move my stick down. All right, taking a look from left to right. As I scan left to right or right to left, notice that it's only hitting my red bar at 1 point. So what you need to know, folks, is that yes, this is a function. Sorry, spelling mistake. Because it passes the VLT. And ladies and gentlemen, we need to further classify it because it is a function. And looking at our data, does it follow a straight line? Yes, it does. So this is what we call a linear function. All right, I'm going to get you to put your thinking caps on, ladies and gentlemen. Think about this question. I want you to think about it for a couple minutes. Maybe even pause the video if you need to. Is every linear relation a function? Okay, think about it. What are our 4 different types of slopes that would help us with that? Okay, a positive correlation, which is kind of like what we have here. It does. If we had a negative correlation, which went this way, would it pass the VLT? Absolutely. We then had 2 different other types of slopes. We had the zero slope, which was this way. And would the VLT work for that? Yep. But the only exception, ladies and gentlemen, to when a linear relation is not a function is when you have a vertical line. You might want to make note of that, because as I go from left to right, notice how it's all on there. So how do you spot a linear relation that's vertical? It's going to be like x equals something. So in this case, let's see where I've drawn it closest to. 1, 2, 3, 4, 5, 6, 7. So x equals 7. So that is a linear relation that is not a function. That's the only exception. 99% of the time it will be, except for if the equation is written in x equals. If it's written in y equals, then you're going to be set. All right, last question here. D, as we go from left to right, we notice our oval hits at 2 spots. Okay, so, oops, haha, undo that. So we notice that this is not a function because it does not pass the vertical line test. Okay, move that up. No, because it does not pass VLT. All right, here's your homework, ladies and gentlemen, from the textbook. Okay, so page 17, numbers 2, 4AB, and 6. Have a great day, folks. And again, if you need some help, see me later. Namaste.